So student, now we are going to study refraction through two media. So what we are going to study now? Refraction through two media. It's refraction through two media. Now students, see. This is water and this is glass. This is water. This is glass. And these are the two media through which we are going to study refraction. Refractive index of water is NW. Refractive index of glass is Ng. This is air. This is also air. Refractive index of air is Na. Now students, see. This is a light ray which is going from air to water. Now students, as we know, light ray is going from rarer to denser medium. Therefore, at this point of incidence, it will bend towards the normal. Like this. So this is the refracted ray for air and water boundary. Now students, see, at this boundary it is going from water to glass. Now again, water is more rarer than glass. So again, as it going from rarer to denser medium, it will bend towards the normal. Now student, at this boundary, light ray is going from glass to air or from denser to rarer medium. Therefore, it will bend away from the normal. At this point of incidence, it will bend away from the normal. This is incident ray. And this is emergent ray. Now student, let's name these rays. A, B, C, D and E. This angle is angle of incidence. Let's name it P. This is angle of refraction for air and water boundary. Now this angle of refraction will be the angle of incidence for water and glass boundary, as these two angles are equal. They are alternate angles. This angle be R. Let this angle be R. Then this angle will also be R. This is the angle of refraction for water and glass boundary. This is the angle of refraction for water and glass boundary. And this will be the angle of incidence for glass and air boundary. And this will be the angle of emergence, which is equal to the angle of incidence. Now student, A, B, C, D, E is the path of light ray which suffers refraction through water and glass and finally emerges out in air parallel to the incident ray. So student, A, B, C, D, E is the path of light ray which suffers refraction through water and glass and finally emerges out in air parallel to the incident ray. So student, A, B, C, D, E is the path of light ray which suffers refraction through water and glass and finally emerges out in air parallel to the incident ray. Now student, we will apply Snell's law at point B, C and D, and we will see what happens. Now student, we know the expression for Snell's law. From the Snell's law, we have N1 sin I is equal to N2 sin R, where N1 and N2 are the absolute refractive indices of medium 1 and medium 2 respectively. I is the angle of incidence in medium 1 and R is the angle of refraction in medium 2. Now students, firstly we will apply Snell's law at point B. Students, see, at point B, light ray is going from air to water. So P is the angle of incidence and Q is the angle of refraction. Now see, applying Snell's law at point B. At point B, light ray is going from air to water. Therefore, we have Na sin P is equal to Nw sin Q, where Na and Nw are the absolute refractive indices of air and water respectively. P is the angle of incidence and Q is the angle of refraction for air and water boundary. Now students, see, sin P by sin Q is equal to Nw by Na, which is Nwa, which is the refractive index of water with respect to air. Now student, let's mark this equation as 1, where Nwa is the refractive index of water with respect to air. So student, we get equation 1, that is sin P by sin Q is equal to Nwa by applying the Snell's law at point B. Now we will apply the Snell's law at point C. Now student, we will apply the Snell's law at point C. Applying Snell's law at point C. Now student, at point C, light ray is going from water to glass, or at water glass boundary, Q is the angle of incidence and R is the angle of refraction. So from Snell's law we will get Nw sin of Q is equal to Ng sin of R, where Nw and Ng are the absolute refractive indices of water and glass respectively. Q is the angle of incidence and R is the angle of refraction for this boundary. We will get sin Q by sin R is equal to Ng by Nw, which is Ngw, which is the refractive index of glass with respect to water. Student, we will mark this equation as equation 2. Now student, Ngw is the refractive index of glass with respect to water. So student, we get this equation, that is sin Q by sin R is equal to Ngw by applying the Snell's law at point C. Now we will apply the Snell's law at point D. Now student, we will apply the Snell's law at point D. Applying the Snell's law at point D. Now students, see, at point D, light ray is going from glass to air, and for this boundary, R is the angle of incidence and P is the angle of refraction. So by applying the Snell's law at point D, we will get NG sine of R is equal to NA sine of P, where NG and NA are the absolute refractive indices of glass and air respectively. R is the angle of incidence and P is the angle of refraction for glass and air boundary. From this we get sine R by sine P is equal to NA by NG, which is NAG, which is the refractive index of air with respect to glass. So student, we will mark this equation as equation 3, where NAG is the refractive index of air with respect to glass. So student, by applying the Snell's law at point D, we get this equation, that is sine R by sine P is equal to NAG. So student, by applying the Snell's law at point B, C and D, we get 3 equations. Now we will multiply these equations. So students, so far by applying the Snell's law at point B, C and D, we get 3 equations. And what are those equations? According to first equation, sine P by sine Q is equal to NWA. This is our first equation. Sine Q by sine R is equal to NGW. This is our second equation. And sine R by sine P is equal to NAG. This was our third equation. So students, these are the 3 equations that we get by applying the Snell's law at point B, C and D respectively. Now we will multiply these equations. Multiplying equation 1, 2 and 3. So student, by multiplying these 3 equations, we will get sine P by sine Q into sine Q by sine R into sine R by sine P is equal to NWA into NGW into NAG. Now student, on the left hand side, all these terms will cancel out each other and we are left with NWA into NGW into NAG is equal to 1. Now student, we can write it as NGW is equal to 1 by NWA into NAG. Now student, we can write NAG as, NAG can be written as the reciprocal of NGA. We know refractive index of one medium with respect to other can be written as the reciprocal of refractive index of second with respect to one. So refractive index of air with respect to glass is the reciprocal of refractive index of glass with respect to air. Now we will substitute this value of NAG here and we will get NGW is equal to NGA by NWA. So student, by refraction through two media, we get refractive index of glass with respect to water is defined as the ratio of refractive index of glass with respect to air to the refractive index of water with respect to air. So students, so far in this class we have studied about refraction, laws of refraction, refractive index of a medium. We have also studied about bending of light rays, conditions for no refraction, and we have seen refraction through two media. Now in our next class we will study about apparent depth, lateral displacement and total internal reflection. Thank you.